Hi guys, today I want to show you how to use an important option of PolyStrips from Curves that I see is not always properly understood. And this option is the normal direction option, where you can choose root vertices. So let's see a practical example. And first of all, we create a plane that is created by the first three vertices. And on this plane we have three sides. One of the sides is basically the one that connects the first to the third vertex, and this is basically the tangent of the curve. And now, because we have a plane, we also have a normal to the plane, and this normal is actually called binormal. And as we have these two vectors now, we can actually find the normal to the curve. First of all, we will look at the candidate normal. The candidate normal is basically the vector that connects the first to the second vertex. And as a normal, though, we have to choose an orthogonal vector to our two previous axes, right? So at this point, we find the normal that is facing the same vector as the first two vertices, but is orthogonal to the tangent of the binormal. Now that we have done this, we can see that the actual polystrip, the orientation of the polystrip, exactly matches these three axes that we just generated. Now, what actually would happen if we move the second vertex? Because the plane defines the orientation, and the twistor rotation is it's basically defined by how the second vertex actually moves. So if we move it downward, in this case, what happens? Let's see. We first define the tangent as before, then we define our plane. At this point, we have a binormal that is actually inverted from the previous example. And then again, we have a normal that is facing the same direction as the first two vertices. So what this means, we have our three axes, and if we generate a polystrip, exactly, the polystrip will look inverted to us. It's exactly the same, but with inverted normals. It is actually a bit difficult to see the strip here because it has inverted normal, so I will deactivate the grid for a second just to show you that the strip is actually there, and I'll put the grid back. So now what can we actually do? We can actually twist the orientation of the curve just using local as a action center and rotating the vertices. That's it. And this option makes the orientation of the strip very stable, so it will always look towards something that you can understand or expect better. So, talking about root vertices, there is one case that needs special attention, which is when we make polylines. Now, polylines can be made with the Create Guides tool, which basically creates this kind of curves for every vertex in your selected polygons. And these guides were introduced by Foundry to basically make better comp tool because they are way more performant than standard curves. But at the same time, they have one thing that is kind of strange, and it's interesting to know. So let's see the vertex order of these guides. And as we can see, like the first three vertices, the first three indexes, like they are not what we would expect. So actually, the second vertex is almost overlapped to the first one, as we can see here, and it has a clear orientation. Not very clear actually, it's difficult to see it, but it has an orientation like this that is very different from all the others. And I suspect the reason is that Modo developers, they want to have a way to actually define a normal of the curve, because curves are kind of warped to the shapes, right? Like they are basically lines in a 3D space, so they don't have a size, and it's to be very difficult otherwise to define a normal for them. So I really suspect that these two small, almost overlap vertices are to do exactly the same thing that we showed before, that is to define a normal for the curve, which in this case would be this one, and the tangent that would be what it looks to be the second vertex, but it's actually the third. Alright, guys, thank you for watching this. I know that it's kind of hardcore, but I hope that this will help you to better understand some of the reason why this option was implemented. Thank you.